How can a computer recognize a bicycle in a photograph? A convolutional neural network learns visual patterns from many images. First, the photograph becomes a grid of tiny color values. Each tiny square is called a pixel. But pixels alone do not tell the computer what matters. CNNs use small filters that scan across the image. A filter examines only a small patch at once. It compares nearby pixel colors and brightness values. When a pattern matches, the filter creates a strong response. This new grid is called a feature map. Different filters search for different useful visual clues. One filter may notice edges where colors change sharply. Another filter can notice straight lines in the frame. Early layers detect simple shapes, not complete objects. The network stacks many feature-detecting layers together. Later layers combine simple clues into larger bicycle parts. Pooling then keeps the strongest information in each area. Pooling makes feature maps smaller and more efficient. Important edges and shapes remain after the map shrinks. The network repeats convolution and pooling several times. With each layer, the patterns become more meaningful. Eventually, the network recognizes whole object-like patterns. Next, the final feature map becomes a list of numbers. These values feed into the network's final decision layers. Each connection helps weigh evidence from the earlier features. The strongest final signal points toward the best classification. For this image, the strongest answer is bicycle. The network learned this by studying many labeled examples. During training, the network adjusts connections after each example. Over time, useful patterns receive stronger connections. That is why CNNs can recognize new images later. CNNs do not see like humans, but they find learned patterns. From pixels to prediction, every step builds on the last.